Today I'm going to talk about Pgpool-II, what, why, and where. And I've selected this topic just because of few reasons. Like Pgpool is around like for more than 16 to 17 years already. Like it's kind of as old as Postgres, but there are so many misconceptions about it. Lots of time I get a question around like, is it should I use PG Bouncer or should I use Pgpool? And because of the name or because of some other misconceptions, like it gets compared with the connection pooler. And today I just want to, this talk wants to explain like what it is and where you can use it and when it's not the best fit and maybe the PG Bouncer or Patroni or some other solution for that particular use case is good for. So this is this is about me. I'm Muhammad Usama. I work at Percona as a software engineer in the Postgres department. Prior to that, I was in Enterprise DB and Hygo, and I'm hacking into the Postgres since 2007, and then around for last 10 years, I'm associated with the Pgpool Global Development Group as well, and I've contributed many features to Pgpool, including Watchdog, the dynamic spare process management, consensus, and quorum-based failover, and few other features as well. So this is the agenda of the talk. So the talk consists of kind of three parts. The first part, I'll try to explain what Pgpool-II is, what are the features it provides, its architecture, and all these architecture, and these are more to explain to explain the decision-making process. Like if you want to use the Pgpool for your particular use case, these are the things you should consider, or these are the things you should know about to consider it for the solution. And in the second part, I'll explain why use it, like advantages and when it is not the best fit. And finally, I'll summarize the talk with what's been happening in the community. And I'll explain the latest version, which was released last month, what are the new things in that, and where the community is heading to in the future, and what are the possible areas of improvement which anybody can contribute to. So before starting, like what the Pgpool-II is right now, I want to go through about the history of the Pgpool, because in my opinion, the name Pgpool-II is confusing somewhat. So it was started in 2003 as a personal project, and Tatsu Ishii was the original author of Pgpool. There was no two in that. That Pgpool was originally meant to be a connection pooler, just like PG Bouncer these days, but it was envisioned as a connection pooler. But eventually, in 2004, native replication and load balancing got added to that Pgpool project. And the reason was that back then there was no streaming replication, there was no Soloni, like the Postgres was like kind of in very early stage, and the replication solution was required. So Tatsu Ishii, the guy from Japan, he's also the committer of Postgres project as well. So he thought it's a good idea to have a replication solution built into the pooler he was making. And again, after two years, in 2006, the project was adopted by a new community that was created around the project, that was Pgpool Development Group. And at that time, the name changed from Pgpool to Pgpool-II, the version 2. And I still believe at that time they should have chosen a different name, because the pooler thing was not the main purpose of the project at that time. At that time, the most usable thing, or the people were using it for replication. And in Pgpool, we call it a native replication, but the replication was the main thing that it was used for, and then the load balancer. Load balancer came because to implement this replication, Pgpool imported the Postgres parser, because it has to identify which selects like all the queries. And reason why it needs to do that was, for example, the native replication, what they do was when a client issues any statement, it just sends that particular statement to multiple servers in hope to get the data replicated. But the problem with this particular solution was there was like, what would you do with the timestamps? Like if user wants to insert a timestamp, like if I send this query to two servers, the server one may have a different timestamp for the same column, for the same row, and server two might get a different timestamp. So they thought that the good way would be to add a query parser in Pgpool, and for such queries which needs like the server specific data, they should be calculated on the Pgpool side and eventually transferred to the client backend side. And that adding of the parser make way for adding a load balancer as well, because now because Pgpool-II knows which kind of a query it got, so it can it can distinguish between read and write statements, and eventually it can route the queries to primary or standby, which is used these days. And down the line, 2023, now Pgpool-II is a complete clustering solution for Postgres, and I'll explain its features. So this is what Pgpool-II today is. So it's not just a pooler; it's a complete clustering management tool for Postgres, and it's quite a rich feature set, and BSD license, that means the most liberal license, is similar to Postgres, and you can just fork it and do it whatever you want to do with that. And the community is very active, and it is actively maintained. Since its inception, Pgpool release one major version every year, and there are multiple point releases between that. And so it's not like a dead community, and everybody, if you post a bug, somebody will pick it up very soon, early. You get the answers in the mailing list. So the community is very active, and the project is going strong since day one. And another good part is it works with all flavors of Postgres. You can hook it up on front of AWS Aurora or any flavor, Enterprise DB's proprietary Postgres or vanilla Postgres or any other Postgres. So these are few of the good points about Pgpool. So now I'll just go through the features and capabilities of Pgpool, which not all of them, but the interesting ones. So the first one is a seamless read-write split. So this is the core of the load balancing, and it is one of the most, in my opinion, is the most powerful feature of the Pgpool. And I believe Pgpool is maybe the only, or there are not many solutions which provides that. And so it can automatically identifies the read and write writing statements and routes them to appropriate Postgres. Like read can get load balance, and the write statements only goes to primary, and because we know like the standby nodes, standby Postgres server, they cannot handle the write statements. And another good part is for the client-side applications, it appears as a single Postgres instance. And you don't need to change anything in the application side. And if your application is designed to work for a single Postgres instance, and eventually, because of the growth or something, or for high availability reasons, you want to make add standbys and the whole standbys with that, and now you want to utilize the standbys, you can just put a Pgpool between client application and Postgres server. For the client application, it will feel like it is talking to a single Postgres server, but on the back end, eventually Pgpool-II will be doing all the heavy lifting and doing the read-write split and load balancing. And again, it is like intelligent enough to identify, to handle replication lags. If the replication lag goes beyond particular limit, it can stop using that standby so that you can get the latest data when the read queries are routed to the standby. And again, the transactions, like if you are in explicit transaction and you issue a write statement and then the read statement Pgpool knows like that particular write statement might not have been shipped to the standby till now, so it routes that to the primary node. So this read-write split is quite like handles kind of all scenarios, and again it provides a very fine-grained control. You can configure the replication lag, how much replication lag you can handle, and the transaction behaviors, what should you do in the explicit transaction, and then DML-based load balancing, like Pgpool identifies if the particular table is updated and the next, in the same transaction, the next statement is not referring to that table, then it can load balance the query. If that object is referred in the same transaction after that was written, then that query doesn't get load balance. And the interesting feature is the query caching. And it is built into the Pgpool-II. You can just enable it by setting allow query caching, and then it start caching all the query results for the read queries. And what this means that the subsequent read query, like the subsequent subsequent query, will be served by the cache rather than going to the Postgres, and it offloads the burden from the Postgres server. And you can provide use two options for the query caching. You can either use memcache server for storing the results for the cache, or you can use shared memory query cache. And then this cache invalidation is very again very what you can say intelligent. Like, if that particular table gets updated, written, or delete from even from another session, Pgpool-II, because it knows which query or statement was executed, it invalidates the particular cache for the table or for the query which was referring to that table. So the invalidation is handled by Pgpool automatically. You don't have to worry about, because this is the most difficult part. If you want to add some external cache on top of the database server, the invalidation part is the toughest part to handle. And finally, there's the cache entry is created at the when the transaction which was selecting the data gets committed. This means that the cache works well for read committed isolation levels, but for other levels, like it might not be best suitable. For example, for it is kind of same as vacuum copy freeze, like, because if the transaction was started after this particular transaction, but Pgpool-II does not have this information about different transactions. So if the first transaction get committed, the next next read statement, the same query which was issued from the second session, but from the older transaction, will still see the data. So this is just one small caveat with the query caching, but other than that, it works very well. And I think read committed is the most used isolation level. So, and what if you want, like for particular table, if you don't want this behavior, you can enable, disable, or deselect any particular table that I don't want the results of this table or this query to, I don't want to cache these results. So Pgpool will omit caching those, but keep caching the rest of the queries. So another feature is it complements the replication. As I mentioned earlier, originally it was kind of the second feature which was built into the Pgpool, that was its native replication. So it still exists there, and although not used very much, but the recent update, we have added a snapshot isolation level on top of this native replication. That means like I think there are not much solution that provides the snapshot isolation for multiple servers. So this and apart from that, it works with Soloni. Again, Soloni is not used anymore, but it still supports Soloni and streaming and logical replication that comes with Postgres. And it gives a lot of functionality on that. On top of that, like for example, it can monitor the replication lag between primary and the standby and take decision for read write split based on the replication lag, and then yeah. So yeah, it can also detect the false primary. If you set up the cluster and there's a node that is not that does not belong to that particular cluster because of some misconfiguration or event, some failover or something. So Pgpool-II can detect it and it can detach it from the cluster so that you always get the consistent and the right data because of the load balancing. Connection pooling. Connection pooling, I think although the name is Pgpool, but I think it is kind of the weakest link of the Pgpool. And to be honest, Pgbouncer does a lot better job than this. And it is very basic as well. It only supports session level connection pooling. There's no transaction level or so this is kind of a basic one. And each Pgpool process maintains its own pool of connections, and then which is configurable, but in terms of connection pooling, this is the weakest feature of Pgpool. Other than that, yeah, it provides extensive management and interface. There's a PCP admin interface in Pgpool, and it comes with 13 built-in utilities, and you can write your own utility as well. There's a protocol, and you can manage, you can monitor, and you can automate so many functionalities of Pgpool using this PCP interface. On top of that, Pgpool show and Pgpool set commands are exposed on the SQL level. Like you can issue them from Postgres client, and they can be used to configure or get the value of particular configuration parameter, similar to the Postgres set and show command. So these commands can be used to monitor or automate a few of the things. Then comes the failover, failback, attach, detach, and online recovery. So these are some extensive set of features to manage, control, and scale up and scale down the Postgres cluster nodes. And then Pgpool comes up with a built-in health check mechanism that complements the automatic failover, and that is used to provide the HA or high availability of the Postgres cluster. And on top of that backend failure detection also hooks up with the watchdog. I'll explain what the watchdog is in the coming slide. That is integrated with the watchdog. That means if the health check of one Pgpool node detects the failure of particular backend or a Postgres server, it coordinates with other Pgpool-II nodes within the cluster, and just to make sure if all the nodes thinks the failure is genuine or it is a false alarm. So that is a very cool feature. And other than that, the failed standby, they just get detached without, and the client never noticed even a glitch. When the primary fails, yeah, maybe some of the clients which are actively using that primary, they need to reconnect, but again, even in that case, the service disruption is very minimal, like maybe for just few seconds. Meanwhile, the time it takes to promote a standby to a new primary. So these are some cool features. And yeah, this is the watchdog which I was mentioning. So watchdog is a HA component of Pgpool-II itself. It solves the SPUF of Pgpool, because if you install Pgpool-II on front of the cluster of, let's say, 3-node cluster, so you'll achieve the high availability of Postgres nodes. If the primary goes down, you eventually another standby will be promoted to become a new primary. But what happens if the Pgpool itself goes down? So because it is the front facing for clients. So this HA or the watchdog, it ensures like the high availability for Pgpool nodes itself. You can install multiple Pgpool-II nodes, and this watchdog channel coordinates if one goes down, the other one picks up, and I'll discuss how it works in the coming slides. And eventually this watchdog plus failover, so this overall builds up a very nice HA solution for Postgres. Now, I'll just discuss a little bit about the architecture of Pgpool, which can be useful if you're deciding like if you should use it for your upcoming project or not. So this is overall. So on the left, you can see the Pgpool child process. The main process forks child process at the startup, and the number of child process, it depends upon the dynamic or static process management mode. This is new to 4.4. Before 4.4, it always spawns the pre-configured number of child process at the start, and each child process handles one client at a time. And when that client goes down, unlike Postgres, the Pgpool child process stays there and keeps the backend connection alive. And when the next client connects to Pgpool, the same process is reused. And other than that, there are PCP process that is used for admin interface. All the utilities, PCP utilities connects to that. This is a management interface for Pgpool. Then this is the watchdog process. This is used for coordinating with other Pgpool-II nodes to make a cluster. And then this health check and worker process. These two processes, they connect to Postgres for health checking. Again, health checking is very configurable. You can set the time for different times and retries for each server. And then this worker process, it checks the replication lag between primary and standby, and based on that, the load balancer takes the decision if it wants to use the particular standby node for load balancing, or should it skip it for till the time the replication lag comes between the allowed limits. So these are the few points I think that needs to be kept in mind before deciding. So it works as a proxy between PG cluster and client application. So there's no direct connection. So that's a very significant architectural point. Like it introduces a hop between Postgres and client applications. And yeah, as I told, it has its own parser, so it inspects all the statements, which eventually has the overhead, and then performs automatic read-write split, which we discussed just a few slides back, and that is transparent to client. So you can just hook up in front of any legacy application. It is a multi-process architecture, just like Postgres, but unlike Postgres, the process stays there when the client disconnects, rather than and the last thing, it uses two-stage user authentication. The first, the user gets authenticated by Pgpool using the same credentials that are given in the Postgres for the same user. Once this authentication is successful, then this user is that connection gets authenticated by Postgres. The reason for doing that is first, because the pool connections, they are already authenticated, so you want to have a mechanism like if a new client wants to use the pool connection, they should get authenticated with the correct credentials. And another point is, for example, with the MD5 authentication, because Pgpool-II on the back end connects with multiple Postgres servers. So what happens is the challenge authentication. Let's suppose the server 1 sends one salt and server 2 sends another salt. and so which salt should be forwarded to the client, and even if we forward that to the client, the result cannot be forwarded to the second server. So MD5 or Scram or all the authentications are implemented within Pgpool-II as well. So you can use any authentication method which is available in Postgres, but that authentication is handled first by Pgpool, and then once that is done, then that is forwarded to the backend Postgres. So these are the few points I think that needs to be kept in mind when deciding for using Pgpool for any application. Okay, now I'll come to the next part. Why use Pgpool? Like, what are the benefits? What are the advantages? So the first use case, which and the most used use case is to gain the read performance, and there are two things in Pgpool, or the two features that gives you the read performance. The first one is load balancing, and the second one is the query caching. And with load balancing, for example, if you have two standbys and one primary, and you distribute the load evenly, so technically you can get twice the overall performance using the load balancing, and similarly to query cache. Like all the cached results, they are just so fast. So the first use case you can consider using Pgpool is for high load or high if you want to achieve like a better performance than the single server, then I think Pgpool can be very useful. This is the query cache benchmark, and it was a very old benchmark, and I took this from one of the Microsoft's blog. Like, I haven't done it myself, and it is like 3 or 4 years old, and we have made lots of improvement after that. And this blog shows that with query cache you can gain 86% performance improvement for subsequent select of the same query, and 20% degradation for the first time. So if your application workload is such like it issues the same query multiple times, and there are so many scenarios like that. So you can get up to 86% performance improvement with just by enabling query cache. And so these are very interesting result, and I've also put the reference of the blog for that. Microsoft use that on a Azure database, but I think the numbers will hold with the vanilla Postgres as well. And another use case would be high availability of Postgres. There are other solutions for high availability like Patroni, and there are other as well. But the thing is, for example, if you have your HS strategy wants you to have two backups or two backups of the primary server. Okay, that's good enough. You can just put in, you can use Patroni or any other high available system which can provide you failover or something. But the problem with with those solutions is the standby servers will sit idle and waiting for the primary to fail so that they can take over in case of a failure. But with the PgPool, you can achieve the high availability, and at the same time those standby server will be put to use. Like they'll be handling lots of read queries at that time. They'll not be just waiting for the primary to fail, but they'll be actively used. So it's a good thing to have to use Pgpool with a high availability for implementing the high availability. And finally, scalability. Like, again, there are functions like attach and then this online recovery in Pgpool that can add, remove standby nodes on the fly. And if for a particular workload where you can expect spikes in your workload, for example, once in a month. So putting the Pgpool on top of the cluster, what you can do is, yeah, just before when you are anticipating the spike in the workload, you can just spin up a new standby using the online recovery, and that will be used for the load balancing. And when that spike goes down, you can just detach that, or maybe just unprovision that particular standby. So you can implement a scalable solution for using Pgpool. Now the other part, when Pgpool-II is not the best choice, and so so for small deployments, and this is the benchmark I did like a few years back, and it was on a very small machine, and just to see the performance of the load balancing, and this if you see in the chart that the green line is the TPS of Pgpool, and the black one, it corresponds to the TPS if you are not using Pgpool and you're directly connecting to the Postgres. So all the database, Postgres, and scale factor was same. So what we can see is, if we have a very small database that actually fits within the RAM of the server, then the direct connection was very fast. And eventually, when we start increasing the number of clients, there becomes the tip of point when the direct connection start becoming slow, and the load balancing gets start giving you a better performance. And for the larger database, the one at the bottom, the, that crossover point was at the very start, even with the 5 clients. My servers was, I just spin up two VMs, and there was just 2 GB of RAM, and these were very small machines. But the point was just to analyze, like if we get a better performance with load balance, or it's not a good choice. So the crossover for any particular server may be at a different state. For a huge server, maybe 1,000 connection. After 1,000 connection, you get the crossover. Or, so that things needs to be kept in mind. If your workload is a small, and then maybe you don't need a load balancer. Why? Because Pgpool is a middleware. It has its own overhead, like it parses the query, and then it adds another network hop between server and client. So it has its own overhead. So the bottom line is, for the smaller workloads, maybe Pgpool is not the best choice. Again, if for the high latency networks and limited resources for the hardware, because again, Pgpool is somewhat CPU intensive, not hugely CPU intensive, but yeah, it has to parse the query, and then it has to forward the query to the Postgres, and then relay back the results. So if the network latency is on the higher side, or the resources, especially if you are planning to host Pgpool and Postgres server on the same host, then and your hardware resources are not adequate, then again the Pgpool it might not be a best fit for that particular situation. Finally, if your only requirement is connection pooling, I don't think so. The Pgpool is the best pooler out there, and it just only support session level connection pooling, which I think is not the best one. So like community is working on adding transaction and statement level pooling, but till that time, I think just for only for connection pooling workloads, Pgpool is not the best fit. So these are the just key takeaways I just listed down all here, and yeah, if the requirement is only connection pooling, I think there are better choices out there. If the workload require query cache result, like read scalability, then Pgpool is preferred. And again for HA, if you do not want to add a hop or a network hop between Postgres server and client, and you just need a failover, then I think Patroni could be a better solution. Although it's very difficult to maintain and stuff, but again, I think that's a better solution. But yeah, if you want to use the idle sitting standby nodes, then Pgpool can be a better choice. So this is just flowchart I try to make, like just for a decision for the perspective when it is better and when it is not. So if the first one, if you need a connection, only connection pooling, just consider PG bouncer, and then load balancing, high availability, and query cache. So if you need any of these or all of these, then you can also enable connection pooling. Then the PG pool is I think the best choice. And again, for the high availability, if only PG failover is required, consider Patroni. Like so this is I think the, where PG pool can be used and where it can is not the best choice. So here are some typical deployments we for the PG pool, how it is. So this is for three node Postgres cluster. You put 2 or 3 Pgpool-II nodes on top of that, and then its watchdog handles the virtual IP. If one Pgpool fails, the virtual IPs get switched to the standby one, and the client's application use the virtual IP to connect to the service. And then you can add like PG backrest or all and PMM monitoring. So this is the bird eye view of if you want to have a cluster with Pgpool and a 3-node cluster with Pgpool for HA and load balancing, and again, yeah, query caching as well. So this is a picture I just took from the Pgpool website as well. It's just to show that you can also install Pgpool along with the Postgres on the same host as well. Like previously, in the previous example, all the nodes was using a different host. So here it is possible to install like use the same host for both Pgpool and Postgres. But again, that would require a lot more resources or hardware resources on that particular server. And yeah, you can also use that with the Kubernetes, and Pgpool also has a Pgpool exporter which you can hook with the Grafana, and it just gives you statistics and everything. For the Kubernetes, you just need only one Pgpool, because if that goes down, the new pod will spin up and it will have the same Pgpool. So there's no need to add multiple pods for Pgpool. But yeah, so this is again a valid deployment. Now to the last part, what's been happening in the Pgpool world. So the latest release is Pgpool 4.4, which was released in end of last year, and it has some pretty cool features. The first one is the new dynamic spare process management feature that I contributed to that. So what it does is actually, previously, if you're familiar, anybody is familiar with Pgpool, there's a configuration parameter that is num init children, and at start of when Pgpool, it spawns that many number of child process that kept waiting for the client connections. The problem with that was this dictates the maximum number of concurrent connection a Pgpool-II can handle. But for example, if you're expecting 1,000 connection just for 15 minutes in a day, but rest of the day you expect like maybe 100 connections, but yet still you have to set the nominal children to 1,000 because there's no other way, and for all 23 hours, these 900 connections, 900 child process will be sitting idle. So that was not very good, a good use of resources. So in the latest version, we have added a new dynamic spare process management. So what it does is like you can just set a minimum and maximum limit, and it automatically ramps up or ramps down, clamps down the number of spare child process. When the load increases, it just keeps spawning the new child process till it hits the ceiling, defined ceiling, and when the load goes down, all the spare child process got killed. And then, then another feature, now you can specify the replication delay time in terms of second. Previously, the only way was to set it in the number of bytes. Again, we have added PG15 support. That means added all the new syntax that was introduced in PG15 and all the changes. And then a query cache. There's a huge speed up. I'll show you the benchmark, but we have reduced the locking in the query caching mechanism, so it has given us a huge performance. So this is the performance benchmark with the new 4.3 and 4.4. So we are seeing like 140% performance improvement because of these new locking mechanisms. And the previous benchmark I showed you that Microsoft did was with the older versions, and that was giving them 86% performance improvement. I'm sure if they repeat the same benchmark with the latest version, they'll see at least 186% performance improvement for subsequent select statements. And without the yellow line at the bottom, this is without query cache. So you can see like the query cache, it just gives you a huge performance boost. And this is with the dynamic process management. Again, like 500% improvement with a huge workload. And again, I haven't done this benchmark myself. I've given the link for the blog post that the person who did the benchmark. And the red one is with the static process management, which was the only possibility before 4.4, and with this dynamic process management, when you want a huge number of child process, you get five times more performance by enabling dynamic process management. So this is again very cool. Other than that, there are some recent noteworthy enhancement, not for the 4.4, but in past year or two, like what we have been doing, what the community has been doing for Pgpool. So the Watchdog, it has got the most number of improvements. We have added like consensus-based failover, as I mentioned in the earlier slide. In case of a backend failure detected by a health check, now this failure is coordinated among all the nodes, and if everybody votes, like if the majority votes like yeah, they are also witnessing the same failure, only then the failover is performed. And if the consensus failed and still that node, that particular node is not able to reach that backend, it quarantines that node till the point it becomes reachable again, or till the point all other nodes also says like, yeah, we started seeing the failure, and then in that case that node gets failover or detached. But till that time it is kept in the quarantine, and then this dynamic membership of Pgpool-II nodes in Watchdog cluster. So yeah, you can if a node is like removed from the cluster, then it automatically adjusts itself for the quorum. Like for example, you started with a 7-node cluster, then the quorum would require at least 4 nodes to be present in the cluster, but eventually if because of some reason you want to few nodes never shows up at the start, so the Watchdog cluster will readjust itself, and the quorum settings, like it will remove the non-show nodes from the cluster till the time they shows up, and till that time, between the time only the number of nodes that are live, they'll form the consensus and quorum. So this is again a very useful feature. The another focus point for since last couple of years is ease of use, because this is again a complain, or we get lots of questions in the community, like related to uh, people want to set up the Pgpool for particular use case, and they want to know, like they say there are so many configuration parameters, so which values they should set. And so one of the focus area we have for the last couple of years is ease of use. For that, we have changed lots of added a new parameter, which if like the clustering mode. So you just set the clustering mode. For example, if you want to use the Pgpool with a streaming replication, you set the clustering mode is equal to streaming replication. That will adjust 70% of the thing according to the for that particular use case, and then you just have to fine tune few of those. So and then we have unified the configuration for the watchdog. Previously, the previous version, like you have to set IP addresses for each watchdog in each Pgpool configuration, and that could be very cumbersome. But with the latest one, you just you just put all the IPs and host names in one file, and then that same configuration file can be used by all Pgpool-II nodes, and you just need to tell which particular ID your this node is, and they'll automatically pick on that particular set of configurations from the configuration file. So that is again very useful. I think I also have a slide to show what different it made. And then there are a few load balancing improvement that previously that is even true for the current version as well. Like because Pgpool can identify if the query is a read-only query or it is a writing statement. But what about the functions? Like if a select statement has a function call, Pgpool needs to know if that particular function is changing the database or if it's just reading it, so that it should not load balance that. So previously, what we have was there was a white function list, and there were a black function, white function, and there are 2 or 3 parameters which you need to set. They also accept the regular expressions, and so that if you know this particular function is a writing function, you just put that in the configuration, so that if a select query contains the call for that particular function, that should not get load balanced. But now, even if you omit that, the Pgpool-II tries to detect it using the volatility of the function. If the function is volatile, it will consider itself that it might be writing to the database, so it will not load balance. So this is one good improvement. And then statement level load balancing is added, I think, a year or a couple of years back. What that means was previously, at the start of the session, the Pgpool-II needs at least 2 nodes to backend nodes to work with. One is the primary, and the second one is the load balance node, which will be destination for the read queries for this particular session. But the latest version, you can set statement level load balancing. That means every statement will select a new standby node. So this is another improvement in that area. Again, the performance, a couple of things I've just showed you in previous slides, like query caching, and there are so many other performance enhancements we made in a few years. And yeah, some miscellaneous update I've just put then, like promote node, logging collector, just like Postgres now, it also had the logging collector, false primary detection, and support for AWS, Aurora, and logical application was added in the previous version as well. So this is what I was talking about, the configuration made easier for the watchdog specifically. The left one was the how we used to do it in the previous version, but with the latest version, you just put everything in the one file, and every single node will pick its relevant configuration from that file. So the pink one was the what you need to do in the previous versions, and the green one is what you need to do now. So it is part of the ease of the use focus we have in the community, to make it so that like it become easier to use. And these are some possible improvement avenues we have. Documentation is not up to the mark, and maybe one of the reason is that it was initiated from Japan, and lots of developers and the community, they are based in Japan. So the English version of the documentation, it is not up to the standards and up to the mark. Connection pooling, as I described, like it's again very basic one, and that needs to be improved. And then yeah, I believe this newly added snapshot isolation clustering mode that can be enhanced in the future, and it can we can create a full-fledged read-write scalable solution out of using that clustering snapshot isolation mode. And because I think that's one of the missing part in Postgres, like primary application, it doesn't exist. So that concludes my presentation, and with that, yeah, Percona is going to add the Pgpool to its Postgres offering in coming month. And to learn about it, do visit our booth in the exhibition hall. And thank you for listening and attending this talk. And if now you have any questions, I'll be glad to answer.
Is it possible to have the client indicate that a read query should always go to the master and not go to replicas?
Yes. So the question is it possible for a client to indicate if the read queries should always go to the primary rather than the standby? Yes, there is a way, and you can, rather there are a number of ways. Like you can always configure if particular query should land up on the primary in the configuration as well, which can be changed on the fly from the client. But yeah, if you put the comment on at the start of the query, no load balance before starting the query, that will always send the query to the primary.
I had a question with regards to the watchdog stuff. When is a good time to use the UDP ping versus when is a good time to use the SQL statement for checking health?
Sorry, when I couldn't get, when is the good time to use the, sorry?
So with the watchdog monitoring that it can do, right, there is the UDP pinging that it can do versus the SQL statement stuff that it can do for monitoring health of the cluster.
Okay. So the question is like for the watchdog health check, which one is, when we should use the query health check mechanism and when we should use the heartbeat. So the thing is, with the latest watchdog, I think you can disable both. So what we have done is the latest watchdog, because it has to coordinate between all the Pgpool-II nodes about the failover, about the state of the health of backend nodes. So even if you disable health check of watchdog health check, it will work like fine, and eventually we will deprecate that in the coming release as well. So there is no need to set the watchdog health check anymore. But for the previous versions, I think again it depends upon the situation, because the life check heartbeat uses UDP, and UDP sometimes has a difficulty to go across the routers. So for that scenarios, if your deployment involves multiple networks, then the query mechanism is better. But on the other side, for the query mechanism, you need one extra Postgres connection on the Pgpool side. So both have good or bad things, but eventually if you're using 4.4 or later, although it's not documented, you can just disable it and it'll work fine.
Can you turn off caching? Like if you have a query that you don't want to be cached, is that a possibility?
Yes, the question is if you can turn off the caching for one query. Yes, that is possible. You can turn off the caching on a particular table, and you can turn off the caching on particular query pattern as well. So you can just say there is a black cache parameter. If you set, you can write any regular expression. If the query matches that regular expression, that will not be cached. And you can list down the tables. If the query reference to this particular table, then do not cache. So it is totally configurable.
I have a question about the caching. Do people use Pgpool and Redis together?
Uh, right now, it doesn't support Redis. It only supports spam cache. But it is
Got
it is
it.
in the radar, and that is maybe the next version or one after that will allow you to use Redis as a cache destination as well.
If you have a transaction, like a begin transaction and then multiple statements, what does it do? Does it send it to the primary always in that case, since it doesn't know if it's going to be a select query or a write query?
Okay, the question is if what happens if you have a transaction, what it will do to the subsequent read queries. If the transaction already issued a write query, then what will happen to the subsequent read queries for the load balancing? So right now it supports 3 modes. You can configure it either way. You can configure it if for any explicit transaction, do not do the load balancing. And then there's another, the second option where you can set for a transaction, if that transaction has already issued a write statement, then the subsequent queries should not be load balanced. And then there's a third option, DML-based load balancing. That if you enable that, that means if in a particular transaction, table do not load balance the queries if they reference the table that was written within that transaction previously. So this is totally configurable.